Hello everyone, I'm really happy you decided to join me and learn more how you can build better domain models by using domain experiments. In just under an hour, I'm going to show you some examples how you can build better models, which can save you hours or even weeks of unnecessary work when working with prototypes instead. Okay, so let's get to the point. Let's start with some story. Let's start with story of some project. Let's call it crowdsourcery. Crowdsourcery is a crowdfunding platform supporting passive investments. Okay, so crowdsourcery had awesome team of experienced developers. Great idea. Was focused on code quality and good design. Followed all the best rules like test-driven development, domain-driven design, clean architecture principles, and applied best infrastructural practices. So it seemed that this team was deemed to succeed, right? So what was the result? Unfortunately, a total failure. So why did it happen? Why did it go this way? So one of the reasons is that we don't know what we need upfront, right? When we are building something, when we want to create something new, then it's extremely hard to predict the future, predict our future needs. So basically, building software and designing the model is all about discovery and learning. So this particular team failed because they didn't realize about it. So instead of revalidating the domain model and finding something Eric Evans calls conceptual contours, they started to build prototype after a prototype. Yeah. And prototype of the product is usually a good idea, but there is one problem with it. Building prototype, testing it, and receiving feedback is usually extremely costly, right? And because it's extremely costly, it takes so much time. The learning rate of learning based on the prototype is also too slow. The main reason is that all our infrastructure, services, and everything technical dramatically slows us down while we might be just want to explore something more about the domain itself. Okay, so maybe let's try to get to the basics. Why do we even write software? So yeah, to solve problems, yeah, and in most cases, we mean business problems. So if I were to summarize 3 points why projects fail, that might be, for instance, CV-driven development. Yeah, that's something that all of us did, and I'm also culprit here. Yeah. So basically, when developers are just trying new stuff, playing with new toys, playing with program languages, frameworks, etc., etc., so that they can be proud they learned something new and can be more attractive in terms of gaining new positions later on. Okay. Sometimes projects might naturally fail because of lack of technical skills in the team, but that's also not the main reason. Because, well, you can always learn, right? If you got the right attitude, you can learn a lot of things. Yeah, good developer can learn new technology in less than a week. So well, that's usually not a huge deal. But the main point why project fail, in my opinion, the main reason is that we are learning too slow. Yeah, we are not adapting our model to new domain findings and requirements. And because of this, we are not having learning loop. The next iterations of the learning loop are not fast enough. So what can we do about it, right? Naturally, we need to learn faster. There is no other way. But the question is, what's the best way to actually gain this knowledge? And the answer is that by experimenting, by practice. Yeah, we all learn the best when trying to do something, when working on something, when learning how different parts interact with each other, based on a concrete experience, based on concrete examples. Okay, now the questions. how we can write these experiments in code. Yeah, is it even possible? So as I mentioned, prototypes might look like a great idea, but because of the feedback loop, because of slow learning rate, and because they are so expensive to actually produce, these are not the best tools to validate our knowledge and learn something new. Mhm. So instead of experiments on prototypes, we can run experiments directly on the domain model, on the heart of the software. Okay. How to run these experiments? I divided experiments into domain experiments into two categories. The first one is something I call the initial experiments. Yeah, so that's basically stuff you do when you are having a greenfield project or creating some completely new feature. Yeah, so in terms of these initial experiments, they're extremely chaotic, but at the same we are learning very fast. And by experiments, I mean trying to find the best model that suits our current needs. Okay. And then there is another kind of domain experiments, which I call life experiments. Yeah. And these experiments are actually here to challenge the upfront decision. So mostly when you are working on some legacy software or interacting with some existing modules. So when you want to try something new, when you got some new findings and you want to verify them, if you want to change, for instance, the model how you apply the discounts, then you might try to challenge the upfront decisions by running live experiments. Okay, so how can we run the initial experiments? Let's start with initial experiments. We usually start with the example mapping. Then we adjust the model according to the examples we just created when mapping some scenarios into examples. Then we need to verify the new model. And by verifying the new model, what I mean is that we need to try to somehow break it or find the limits of the model. So if we got some requirements, we need to check if these requirements are actually can be expressed and can be implemented using the current domain model. So when you are verifying the model, it's always very, very chaotic, yeah, trying to do stuff. So at this point, you might want to try to have pair programming or mob programming. I'm usually against it, but that's the good use case for it. And I even coined the term code storming in this step. So basically, you are not just placing stickies on a board or something like that. Instead, you are all experimenting directly on code, directly on the domain model, and having good findings about it. So the steps of the code storming would be to challenge the model, try to break it, as I mentioned. Then ask the others to challenge the model. Include as many people as you can, right? So they can give you some good insights about it. And if you are working in small teams, ask everyone from a team to have a review. So if you were unable to work with all of them, yeah, because of some limitations, at least try to ask the rest of the team what they think about it. Yeah. Again, that's all very chaotic, but this way you are sharing the knowledge, sharing the domain knowledge and important insights with your team. Yeah. So that's the whole point of it. Okay. So that was about the initial experiments. What about the live experiments? So live experiments also start the same, and they look quite similar. The difference is, though, that you are actually trying to change something which exists. So you're not creating a new feature, you're not building new stuff, you are not starting a new project. You are actually working on a living system. So what I usually do, I try to have an isolating branch, yeah, and something the naming like experiment and a number of experiment and the feature name usually works good. Then again, you're also running the code storming part, but the difference is that you rarely actually create something new here. you try to change the existing part of the model. So what you can do, you can try to actually modify the existing code of the domain model. But the problem is that sometimes it's very hard to do, and you don't know all the details. So instead, what you might do, you can simply copy paste the existing classes and then start working on them. Yeah. So in an isolated branch. Yeah. Okay. Copy paste here is not so bad. Yeah. Then you ask for a review, ask others to challenge the model, and to share it, right? To share the knowledge, to share the findings. And if experiment is accepted by everyone, then you can merge your changes. Or if you cannot merge it because there are some compilation errors and that kind of stuff, or simply it doesn't work in technical terms yet, at least try to gather the knowledge you have accumulated. Yeah, you got some good finding. If your experiment about if changes to your domain model, if changes to the code supporting your domain model are actually accepted, it's important to record it somehow. And you might not be ready to merge everything together yet, yeah, because of all the technical stuff, but you should at least try to share your findings. And if you cannot merge it, create a new feature branch, or if you're not using branches, just start focusing working on some new feature. And then what you do is you actually start to polish the code based on the experiments you've just run. Okay, so the important thing about live domain experiment is that the feedback loop needs to be short, right? It's all about short feedback loop. So these pull requests with these experiments shouldn't last longer than 1 day. And also, to be able to actually run experiments, domain experiments, either initial experiments or live experiments, you need to have the right team. So you need to have a team which is willing to challenge the previous decisions and is willing to learn. If you got team which is not ready for it, basically it won't work. Yeah, you're doomed. You shouldn't even try introducing them experiments because you will waste your time. Yeah, since there is no cooperation, if you got no team which can actually support you in running experiments and with which you can share your knowledge, then it's just waste of time and might lead to a lot of frustrations. So to sum it up, if experiment is accepted, you should keep track of your model changes. For that, you can use, for example, architecture decision records. Yeah, you can save them in some Markdown file. You can use some tools to generate them. It's up to you. And this helps your team, and especially new members, to understand why you made such decisions regarding the domain model. And it might be also very useful when at some point in future, someone might want to challenge your previous decisions. Then you might point to the concrete ADR and say, okay, yeah, I know what you mean, but we decided to actually build it this way because of this and this, yeah? And then you share the full context of the experiment. So basically, you should store the results of experiments in ADRs. Okay. So I said that in both experiments, initial experiments and live experiments, you start with the example mapping, yeah? So what's so special with example mapping? In my opinion, there is no better way to learn than by concrete examples. And these examples can also help you to clarify the requirements and talk with your clients and business experts so you can have concrete examples how the system should behave. And usually by examples, we can understand and the business can understand what they really need. Okay, so now the sweet spot is when you combine example mapping with test-driven development, then it works just great. And I'm going to show it to you. So let's see domain experiments in action. Okay, so here I'm having a repository with the examples. It's a public repository, you can check it on your own. But now I'm going to show you it on live. So let's switch for a moment here. Okay. So when we start a completely new project, we got nothing. So what I'm going to show you now, I'm going to show you how to run initial experiments. Let's start with running initial experiments, because live experiments are usually run the same way, but the difference is they are a bit more isolated. So we usually use a separate branch and that kind of stuff. So when we got nothing, there is nothing in the code yet. Which we have just very vague definitions, some very generic concepts here, like value proposition, some initial requirements, and that kind of stuff. Yeah. So, for instance, the value proposition is that crowdsourcery allows investors to invest into any kind of asset. Then borrowers can repay loans. Crowdsourcery is a fundraising platform which allows investors to allocate their money passively into groups of assets using automated strategies. So that's our value proposition in crowdsourcery. There are some very initial requirements, like any borrower can start fundraising to finance her project, investors can invest into assets, investors receive returns based on the asset they invested in, and borrowers will receive funds to finance their project based on the schedule. So this is what we need. This is what we have so far. Yeah. So no code, nothing, just very generic description. How can we start? Yeah, with working on the project. So what I do is I usually switch to the board first. So what I do is I start with some, the very initial versions of a big picture of event storming. So big picture stage of the step of the event storming session. In the real example, when we were working down on some real project with some existing domain, then the big picture would be very, very huge here. Yeah. And for the ones who might not have used event storming yet, the idea is that you gather as many people as you can to the same room from different areas who have some understanding about the domain of your system, both technical and non-technical people. And you ask them at the very, very beginning of having a completely blank page, you ask them to actually start adding stickies. This can be, for instance, orange stickies, but it's not important. The idea is that these stickies express some important facts, some important events called domain events, which happen in the system you are currently having in mind. And when you would be running a big picture for the legacy projects, then a lot of stakeholders, a lot of developers are actually having their own vision how things work. So then you might have the full wall of orange stickies, really hundreds or even thousands of them sometimes. So a lot of them actually. And then when you are actually starting something new, completely new, either new module or completely new project, you might not have the vision what you are currently building. You might because you have not faced all the difficulties with the project yet. Yeah, you just might have some very initial thoughts what you might need, and then the big picture is usually much smaller. However, it might be still useful. And here's the example of the very, very initial version of the big picture session. And there are things like project fund, and you see it's duplicated, but it's not a problem. It happens like that in real sessions. Then there is project start, can be project started, project cancelled. This project repaid, schedule accepted, deposit made, funds received, project defaulted, funds withdrawn, payment not received on time, project cancelled. So a lot of things from different areas, completely assorted, without any time order, without any processes found out yet. Yeah, so it's just a brain dump of our ideas, what we want to build. And this is usually what we have in our heads when we start something completely new, nothing more than that. So what we do next is we need to try to actually somehow organize stuff. Yeah, and in the big picture, after the big picture, or the initial step of the big picture, what we do is we try to find some processes. Yeah? Some processes inside it. So we try to order events according to time, according to reason why what even happened, yeah, to the sequence of events, by finding some processes. And there are multiple techniques for this. For it, there Alberto Brandolini mentions, for instance, pivotal events or swim lanes. Or you might try to divide your time into different sections and then try to organize stuff. So there are different techniques how you might actually start looking for processes. But right now I'm going to show you the result of this of finding processes here, and it might look like this. We found out there are two main processes in our system. The first one is fundraising, and the second one is investing. Yeah, fundraising, when someone wants to actually start a project, gather funds for it, and investing when an investor wants to invest in the projects, right? So these are two different processes, and for the needs of this presentation, I'm going to focus just on the fundraising here. So the fundraising process looks like this: the borrower registered, then schedule can be accepted, then project can be started, project can be cancelled, or funds can be received, and finally project might be funded. Yeah, so extremely simple stuff, but should be good enough for the needs of this presentation. And then what I usually do after having these processes, yeah, by starting from basically nothing, what we might do is that we try to create examples of some basic use cases here. Yeah, and this is the step which is called the example mapping I mentioned previously. So in example mapping, we try to find some main use cases. We don't need to cover all of them. Yeah, we just want to. These are use cases here. We might want to actually just gather some of them and then focus on the one selected use case. And for example, we might focus on starting a project, right? And starting a project is composed of a collection of events. Sorry, not events. A collection of examples. Yeah, and the green stickies here are actually the scenarios of examples. So, for example, it's okay when less than $10,000. You can start it without any further verification, but need to be verified manually when more than $10,000. Then there is the one when schedule is accepted, and the one when schedule is not accepted. Also the one where adult borrower starts a project and borrower without criminal records starts a project, right? So you are not necessarily writing all the given, when, then stuff here and all the details. You are just describing some examples, some scenarios as examples. So for example, the example where adult borrower starts a project, yeah, or the one where where borrower without criminal record starts a project. When you have some findings, you can actually start grouping them into roles. Yeah, some people might try to actually create roles. These blue stickies here, which tell us what are the rules underneath, like project must be verified, or only verified borrowers are allowed to start the project. Yeah, that kind of stuff. But what I do is I usually start with the green ones, with just the description of the examples, and then I let the rules emerge as we get deeper into the examples. And now the important thing is that you might go to the next step of the event storming session, namely to the design session, and start pasting stickies telling you about the concrete examples, like who accepts some command, for example, some aggregate accepts some command and produces events like that, and there is some policy and that kind of stuff. You could do that, but based on my experience, design level session is usually a bit more technical one, yeah, and involves less people than a big picture stage of the session. So usually you're left with techies or general programmers, yeah. So if you're trying to design your findings based on these examples, then why not go straight to the code, in fact, yeah? And that's what I do. When I have the example mapping, we go to the code. So when we got some few examples, there's no need for me to start adding more and more and more and more. And after a week of working on it, go to the code. What I do is I try to go immediately to the code, because code is the only source of truth and will help me to clarify all the requirements and find a lot of inconsistencies. Yeah? So let's get into the code storming. Yeah, I'll switch to the code, to the IDE again, and you see we got nothing, completely nothing, not a single piece of line, maybe of some generated code. Yeah. So what I do now is I create actually some initial examples, like we see starting a project. Yeah, this is the use case, starting a project. So let's create it, starting a project examples. Yeah. Okay. And we will start expressing these examples as tests. Yeah. I am using Jupyter here, so I can give meaningful descriptions, like starting a project examples from the example mapping session, version 0, for instance. Yeah, because that's how it's named here. That's the first version. And then what we do is we actually start writing concrete examples, like adult borrower starts a project. So what I do is that I do something like that. A borrower can start a project. We are starting, to remind you, we are starting with the initial experiments at this stage. Yeah? We got something, we got nothing, we are just having a greenfield. So a very initial overview, according to our examples, a borrower can start a project, something like that. Okay, start project test, and we got nothing. Yeah, we got no code, nothing yet in the system. But our code and our language will start to emerge, and all the relationships will start to emerge according to adding more and more examples. So what I mean is that we don't have a borrower, right? There is no such a thing. Yeah, but let's simply create one. Okay. So we get a borrower. Okay. So now can start the project, right? So if borrower needs to start the project, we need to have something which actually runs some process. Yeah, that can be a function, or that can be some object. It depends on the language you use and on your preferences. So let's just say that there is some system. Yeah, the name is not at this moment important yet. Yeah, we have some system which allows you to actually start a project. So what we can say is something like, I don't know, project starter maybe, or yeah, basically you could write anything here at this point. You will find it during next iterations what's the best name for it. So what we can do now is we create this kind of this class, yeah, the same way. Okay, so we got the project starter. Okay, and when we got the project starter, what we do is we need to start the project, right? So start project. Okay, we don't have such method, so we add it. Okay, So we got a method start project inside the project starter. Yeah, and now what we need to do is that we need to express some things that happen in the system. Yeah, and we can implement it in different ways. But usually, when you're modeling domain, it's a good idea that everything that happens and everything that's important can be expressed and implemented as domain events. So what I do now is I tell, yeah, I want that this method returns some events. Yeah, it can publish events directly if you wanted to, and you could inject some domain event publisher. But I personally prefer to have just simple functions which returns stuff instead of interacting with some event publishers and or maybe piece of infrastructure. So I prefer it this way. Okay, so I basically created. Okay. Yeah, and I'm having a domain events, but this method is not returning domain events yet. So let's make start project to return domain events. Okay. Yeah. It's not about implementing everything which is correct. You see there's, for instance, null, yeah, but it's not important. It's all about building the language at this moment. We will get into details with more and more examples later on. So now what I can express is something like has occurred event of type, something like that. Okay, so we create it. Okay, and go back. Yeah, so has occurred event of type here, and we say, for instance, that project started, right? Project started, something like that. So we need to create one. Yeah, record. Okay, that would be proper domain event. Yeah. Okay, so create interface. Okay. Okay. So project started here, and then we need to add this argument here. And now what we want to assert is that actually this happened, right? So let's say that this method should return Boolean. So project was started. Okay, and let's make it to return a Boolean. And then let's simply express it. Project was started, yeah. And let's use, for instance, asset j here. Assert that is true. Yeah. So that kind of stuff, which allows us to run it, yeah. We got some pieces of code which appeared from nothing. It doesn't pass yet natural because we have not implemented all the details inside it, and I'm not going to implement it now because, well, we got about 17 minutes left. So instead, I'll go with each commit then and see what's the progress and show you what's the progression of changes, right? But I wanted to show this very, very simple case of actually creating some examples because it shows you how we can start proceeding without having nothing at all during the initial experiments. Yeah. Then what we would do, we would create a next example, and this can be more a more concrete one, like given any adult borrower when start the project, then project is started. Yeah. And then yet another one according, yeah, it doesn't need to map one by one to the stickies. Yeah, usually one green sticky adult borrower starts a project, for example, in code is expressed as a lot more examples because we are expressing concrete examples. Yeah, this is just a generic description about the example, but when we go to the code, we need to express all the edge cases and that kind of stuff, right? So then what we might have, like given borrower who is younger than 18 years old when start the project, then project is not started. Yeah, that kind of stuff. And what I'm going to do now, I'll reset these changes and switch to the following comment here. Okay, so let's do that. Okay, and let's go to the first step. Okay, and that's how it looks in the first step, which is kind of similar which is kind of similar to the changes. Let's drop this one. Wait a moment. Let's clean everything here. I forgot about cleaning stuff. Okay. Yeah. So that's how it might look like in a bit more organized version. Yeah. So we are having the class is called, for instance, examples from Miro here. Then inside it, we got a scenario of starting a project, and this is expressed as a nested class inside it, and then Jupyter. And then inside starting a project, we are having more and more examples, like given adult borrower, when borrowers will start a project and project is started successfully. Yeah. And when I organize the code and clean it a bit, you see it's important that the expression of the test is also expressed in terms of some domain DSL. Yeah. So there are some object mothers or test build factories introduced, which instead of calling the constructors and passing some arguments, are actually trying to express stuff like any adult borrower, and then borrower wants to start a project. When borrower wants to start a project, then we express that project has started. Yeah, something like that. So it's a bit more readable than in terms of reading the test, especially when you would like to share your findings with non-technical team members. Okay, so the next step would start adding more and more examples, like I've just tried it previously. So here we have an example of given adult borrower and borrower wants to start a project. Yeah, that's the previous one. And then we got another one. Given borrower who is 17 years old, when borrower wants to start a project, then project is not started. Yeah, and it is by adding more and more examples, our production code starts branching, starts supporting more edge cases. And when we add more and more concrete examples, our production code would start becoming more and more generic. Yeah. So what we have here, let's take a look at the code of start project command handler here. Yeah, and that actually introduced the first branch. Yeah, so extremely simple stuff, but by adding more examples, our code starts branching and starts supporting more stuff, right? So that would be the very first if in our application. Then we go to yet another step. And what we can do, we can start expressing more stuff, more detailed way. Yeah. So we want to say that borrower who is younger than 18 years old, when the borrower wants to start a project, then project is not started. Yeah. And we express it by using, for instance, parameterized tests. Yeah. So when borrower is 17, 16, 8, 4, 2, or 1 years old, then it cannot start. It cannot be started, right? So the project cannot be started. And that's how it looks in the report. Yeah, the report is quite nice. You can even start sharing with the rest of your team and start sharing some knowledge and your findings about your initial experiments on the domain directly. Yeah, what's important, you see that we are focusing just on the business rules here. There is no application layer, no infrastructure layer, no databases, no UI, and that kind of stuff. We are just working and experimenting on the domain itself, on the domain model itself, right? Okay. Then to the third step, or step number to the fourth step, actually. Yeah, and here what we did in this step, nothing actually changed in terms of the expression, but the implementation changed, because the previous implementation of the command of the borrower was such was extremely naive, and simply used the value object age here, which didn't make any sense, right? So we changed it with birthday. So small changes, small incremental changes to the model. So now the fifth step here is the important one, because there is a first breakthrough, and let's take a look at this. Okay, So the thing is, when we started working of starting a project scenario, we actually noticed one thing. We allow only adult borrowers to start a project, but do we even want to have not adult borrowers in our system? After all, it's all about investing, right? So we shouldn't even be able to someone to register when she's younger than 18 years old, according to some other rules, right? So that's our first finding. And what it actually changed is that irritated us to create a new example here. And the new example and new scenario would be something like new borrower registers. And here in this scenario, new borrower registers, we express which borrowers can actually register in the system. So at this point, we moved the check-in from our project starter part to actually registering stuff. So and we say, okay, so no one who's younger than 18 years old can create the account, can register their account. So we found on our next rule after we were thinking about it, and that's the first breakthrough. And our new finding in the domain, which should be shared with all the others, and if it's accepted, we should proceed. So the example would be like only adult borrowers can register their accounts. Yeah, and here we are having again a parameterized test expressing that new borrower registers and only adult borrowers can register their accounts. And when we run everything according to this scenario, new borrower registers, there's also another set of examples. Borrowers younger than 18 years old cannot register their accounts. Yeah. And then we again say what's the given birth date and the current date, and this borrower is or is not allowed either to this two set of examples. So this is a breakthrough, a little breakthrough, yeah, because we got nothing yet. We started with absolutely nothing in the code. So, but this is actually a breakthrough which gives us some more insight. So based on the code said us that maybe not the code said that, but the code shown us and allowed us to start thinking about it. That okay, maybe it doesn't make any sense, right? When we are working on it. So the adult borrower starts a project is removed from starting a project scenario, and instead it's moved to the new scenario, new borrower registers, and then we have more than 18 or less than 18 years old, right? And that's the idea behind it, that instead of adding more and more and more and more stickies, which are not contributing as much to our domain language as code directly, and we might not be finding all the details, instead we go to the code, and then we might have some feedback, and if we want to, we might actually add this finding on the my report, for instance, or simply write them somewhere if you feel you might need it. So there is a feedback directly from working with the code to the ways that to the rules how the system might actually work. Okay, so then we might start adding things like adding application and infrastructural layers. So our system might actually do something. So for example, I've created a primary adapter start project command line interface, which calls directly to the start project primary port. I decided to apply ports and adapters architecture in such case. So when we started, we were focused just on the domain package, nothing more, right here. But after having some initial rules, some initial code, and something that might actually be shipped, we might want to start adding adapters, infrastructure, and use cases all around it. Yeah. Then going next to the future, we might go actually to more examples, like starting a borrower with or without a criminal record. Yeah, these are next rules. And again, according to our finding, most probably we don't want to allow users which has criminal record to even create our account. So after the previous finding, we when we start thinking about criminal records and starting a project, we don't even say, okay, someone with criminal record can start the project. What we say is that, okay, someone with criminal record cannot register her account, right? So that would be the next example. Person with criminal record cannot register her account, and that would be the one here from this step. And then again, we start branching, we start adding more and more examples, we start expressing it. So for example, when borrower register, and then you see, if we want to register, yeah, we need to have something which registers. We call it the borrower registry, and register is something which we call it register form. Yeah, we don't need to give the final names yet, but we need to be open to start refining them in next iterations. But the name registration form and borrower registry sounds nice and actually can contribute to our initial understanding of the domain logic. Remember, we don't have any working project yet, any working software yet. So we don't have names. We are finding names. We are creating names. So that's why it's called initial experiments, actually, right? We can ask, okay, so borrower registry, register form, and then some rules around it, etc., 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 which immediately can again make some new findings. So actually, we don't want borrower without criminal recourse to start a project, and you see that starting a project isn't really about user accounts, but it's really about some rules regarding starting a project, like, okay, when less than 10,000 or need to be verified when more than $10,000. So instead, we move to the we got new concept, borrower registry. And here in the new borrower register, this is actually the place in this scenario where we try to express this stuff. So you see, there is even a new definition found out in code. So going a few steps more here, I'm going to show you something more, and then what we have here is that our starting a project scenario started to add in more and more roles, starting to have more and more roles. So that's the new role taken again directly from here, from the examples about the cost of the project, and then said that given project proposal of $9,000, when borrower wants to start a project based on this proposal, then project is started successfully immediately, right? So you see there is even a new name, project proposal, somewhere here, right? So we got project proposal stuff, and even something which seems as project proposal supervisor, yeah? So project proposal is something that user shows to the project proposal supervisor, yeah? So then new role, next example, sorry, given project proposal of 10,000 total value, when a borrower wants to start a project based on this proposal, then project needs to be verified first. And then we say when we are having project proposal of total value $10,000, when a borrower wants to start the project, then we have that events has occurred any event of type project request accepted for verification. Yeah, so that's the new name you see here, project accepted for verification. So new namings, new stuff is actually we are finding new stuff actually directly from the code. So you see there in next iterations there is new name like project proposal, new definition of project proposal supervisor. So we are actually started building ubiquitous language out of nothing. And then we have events like project proposal accepted for verification. So you see that our starting project example actually started evolving just by looking at the examples written directly in code. Okay, so that's the way we can iterate in initial experiments. We got just 10 seconds, and I said that I want to focus on on the initial experiments. But just a few words of life experiments. The life experiments work exactly the same as initial experiments, but the only difference is that when we do stuff new, we usually create a separate branch like here. Then we copy paste some stuff. We name it like experiment, for instance, in a package. So, for example, when we would like to start working on managing a project, and then we had some existing code, but we wanted to run something more about it. So, what we actually did is that we sorry, here in funding project experiment here. Here we are actually having a new package experiment. And what we did here is copy pasted some code and started working just on the isolated domain module, right? And then we can start changing the existing code according to the rules of investing into different groups of assets. Yeah, that's something I've not shown you previously because of the limited time. But I just wanted to focus on the initial experiments, so you can see the whole process instead of talking about branching and grouping code into packages. Yeah, so basically that would be all about the demo and about the presentation. So thank you very much. If you enjoy it, I'm really happy. You might visit my website howtobe.pro where I'm teaching stuff like this, how you can write better software, build better domain models, cleaner code, and how you can use example mapping and test-driven development to produce possibly best code. You can also contact me at my email, mike@wojtyna.pl, and or just connect me on LinkedIn. Would be more than happy to answer all of your questions and connect. Let's exchange some thoughts, and well, let's get straight to the question. Thank you very much. Okay. Yeah. Okay. So the first question is what matter is quick learning. As it was mentioned, coding activity may slow down the learning. I often saw devs not talking to domain experts or not reading resources. Why not start with this? You actually start with this, but the idea is that when you just start posting stickies, for example, you might not find the inconsistencies in your domain model. Yeah. The other thing is that all the findings may actually come when talking on the direct examples. It's not always easy to extract knowledge from your domain experts without having some concrete examples. You might think you understand something. You might ask them, and it seems that it's okay. But after getting into the details, into the examples, you actually start learning about all the branches and about all the rules of your system. So yes, you start with talking to domain experts or reading some initial vision of your product, but to fully understand it, in my opinion, you need examples, and it's best to express examples in code directly. Okay. Jak umiejętnie zaimplementować model domenowy? Ojej, to jest bardzo ogólne pytanie. Natomiast gdybym miał odpowiadać na takie pytanie w sposób równie ogólny, to powiedziałbym że istotne jest to, aby nasz model był w stanie wyrażać potrzeby, tak? I to jest właśnie ta część, którą mówiłem odnośnie code stormingu i ewentualnie tego mob programmingu, które się tam dzieje później, że próbujemy zepsuć model, w sensie mamy jakieś wizje, mamy jakieś feature'y w naszym modelu, chcemy coś tam poprawiać, to, co powinniśmy tutaj zrobić, powinniśmy być krytyczni wobec tego, czyli jeżeli mamy jakiś model i ten model przestaje wyrażać nasze potrzeby, przestaje pomagać nam realizować to, co trzeba, no to w tym wypadku nasz model nie jest właściwy i powinniśmy zacząć iterować. Testy BBD, probably, miało się raczej na myśli BDD, czy naprawdę są potrzebne? Moim zdaniem dzięki temu możesz drive'ować wytwarzanie oprogramowania w taki sposób, jak ja to pokazałem. Dzięki temu mamy możliwość tak naprawdę od zera, od niczego wyjść z konkretnymi kawałkami zachowań systemów, zacząć je rozumieć, zacząć krytykować pewne decyzje, które były podjęte wcześniej, albo zacząć krytykować pewne rzeczy, które usłyszeliśmy od ekspertów domenowych, jeżeli okazuje się, że one są niespójne, bo często jest tak, że eksperci domenowi oczywiście gdzieś tam jakąś wiedzę mają, natomiast ich wiedza na temat tego, co tutaj byłoby do zrobienia, nie jest wystarczająco specyficzna i nie uwzględnia pewnych szczegółów tych modeli. Więc w tym wypadku ja uważam, że czy potrzebne? Nie, nic nie jest potrzebne, tak? Ale na pewno to pomaga w rozumieniu domeny, a uważam to za kluczowe dla powodzenia projektu. Okej. Jak często masz styczność z podejściem Driven Development? Czy Driven Development zawsze wiąże się z większym nakładem pracy? Masz na myśli pewnie Domain Driven Development, więc albo ewentualnie tutaj w połączeniu z Test Driven Development, tak? Bo ja tak naprawdę te rzeczy ze sobą łączę. Czy jest to większy nakład? Nie powiedziałbym, że to jest większy nakład pracy. Może być iluzja, że jest to większy nakład pracy, jeśli zaczynasz od czegoś prostego, masz na przykład CRUD'a i mówisz, no dobra, no to jak mamy CRUD'a, no to co, no to ja sobie zaklepię jedną adnotację gdzieś tam w Springu, zrobię z tego Spring REST Data, udostępniam i mam udostępniony cały serwis, gotowy i można sobie CRUD'ować, co tam potrzebujemy. I czy w tym wypadku, jeżeli faktycznie takie byłyby realne potrzeby projektu, czy Domain Driven Design ma sens, przepraszam? Nie ma sensu, bo tam nic się nie dzieje i na pewno nie warto od tego zaczynać. Natomiast z mojego doświadczenia sprawa wygląda tak, że tak naprawdę rzadko kiedy robimy system, który ma być kolejnym CRUD'em. Jeśli robimy nowy system i inwestujemy w to środki jakieś i staramy się zrobić coś dobrego, to raczej nie po to, żeby zapisać i odczytać dane, tylko żeby zapisać dane, przeprowadzić jakiś proces na nich i później ewentualnie odczytać wyniki tego procesu. I ten proces to jest właśnie to, gdzie Domain Driven Design lśni i tak naprawdę Domain Driven Design w połączeniu z Test Driven Development i tymi eksperymentami, które pokazałem, mają sens w kontekście części systemu czasami. Zdarza się, że nie cały system tak budujesz, na przykład jak masz tą CRUD'ową część, to tego nie robisz, bo to strata czasu, ale wchodząc w szczegóły jakiegoś tam modułu, tam Domain Driven Design jak najbardziej może mieć sens, tak? W połączeniu na przykład z Test Driven Developmentem, eksperymentami domenowymi i tak dalej, i tak dalej. Więc zdecydowanie w ten sposób też można to podzielić. Natomiast pytając, jak często mam styczność z takim podejściem, staram się dobierać projekty, w których mogę użyć to podejście, więc szczerze mówiąc dosyć często to jest jeden z takich dla mnie wyróżników, czy zespół jest dojrzały i fajnie się z nim współpracuje. Co jako tako sądzisz o Test Driven Development? Coraz popularniejsza staje się ta metodyka i gdzieniegdzie wciskane jest to na siłę, bo to jest dobre i każdy tak robi, to my też tak będziemy. To jest wspólne w sumie dla każdego nowego, może nawet nie nowego, dla każdej w sumie sposobu, dla każdego sposobu wytwarzania oprogramowania, dla każdej technologii, dla każdej biblioteki. Możemy powiedzieć, czy nie jest to przypadkiem wciskane na siłę. No i odpowiedź bywa, że tak, że zdarza się. Natomiast ja osobiście uważam Test Driven Development za w sensie, gdy odkryłem test-driven development, ale w rozumieniu prawdziwym test-driven development, w sensie nie na zasadzie robimy coverage, nie piszemy testy jednostkowo, tylko myślenie na zasadzie, OK, mamy egzample, które sterują wytwarzaniem oprogramowania, sterują naszymi potrzebami, tworzą nasz domain language, tworzą nas ubiquitous language, tworzą nasz domain model i to wszystko się zaczyna zazębiać, to wtedy stwierdziłem, wow, kurczę, to jest naprawdę spora zmiana, więc osobiście dla mnie to był jeden z punktów zwrotnych w mojej pracy jako programisty i uważam, że mi to dało bardzo, bardzo dużo. Natomiast trzeba rozumieć, że oczywiście nie wszystko ma sens w każdym case'ie i tak samo jest z test-driven development, tak jak powiedziałem wcześniej na tym przykładzie z CRUDem. Jeżeli rzeczywiście byśmy mieli jakiś moduł systemu, który jest po prostu CRUDem i na razie wszystko, co o nim wiemy i kiedykolwiek będziemy wiedzieć, to że na razie jest CRUD, no to nie próbujmy tam robić TDD, tam nawet w ogóle nie próbujmy pisać testów jednostkowych. To, co zrobimy, po prostu odpalmy proste testy integracyjne, które zobaczą, czy jak zapiszemy jakieś dane w bazie, to te dane w bazie można odczytać i w sumie tyle, tak? Nic więcej tam nie trzeba, więc powinniśmy aplikować kontekstowo i jeżeli miałbym powiedzieć, kiedy TDD i kiedy ogólnie TDD, wtedy, kiedy mamy procesy, które chcemy odkrywać i które chcemy implementować, czyli kiedy mamy system, w którym faktycznie ta część procesowa jest ciekawsza, a nie nasz system jest tylko CRUDem. Ja na przykład nie stosuję TDD do infrastruktury, nie stosuję TDD do warstw aplikacyjnych, prezentacji i tak dalej. TDD stosuję tylko do części, tam gdzie jest proces, czyli tam gdzie jest jakaś logika. Okay, so it seems that's all. Thank you very much again. All the recording would be available on YouTube and Facebook. So thank you very much and thanks for the questions. And hope my presentation is actually going to save you a lot of time when you are building domain models instead of producing costly prototypes. Thanks a lot. See you.